Hello and welcome. My friend sent me this image and asked me to solve this problem. The given green region is of a quarter circle, the horizontal axis of quarter circle, and the line of 12 units are parallel. They are also tangents to the red circle. Find the area of the green region. The major challenge that we face in these kinds of problems is less information. Like in this case, we have only the information of the tangent. We don't know how to proceed. We don't even know if there is a solution, and if there is, how many solutions are there. We will be solving this problem using two approaches. In the second approach, we will solve it in a very intuitive manner, and there will be very less calculations. So let's begin. Approach 1 is using algebra and geometry. If the radius of the smaller circle is smaller, its diameter becomes 2 times smaller. Distance between the tangent line of 12 units and the horizontal line of the quarter circle is 2r. And if the radius of the larger quarter circle is capital R, the diagonal area line becomes capital R2. Here we can clearly see there is a right angle triangle forming. So we will be exploiting the Pythagoras theorem and putting it to our leverage. Now we need to find the area of the green region. This can be simplified as the quarter area of the larger circle minus the full area of smaller circle. This can be rewritten as area is 1/4 of pi capital R squared, that is the area of the bigger circle, minus pi small r squared, that is the area of smaller circle. If we simplify it, this becomes pi by 4 capital R squared minus 4r squared. Now we will be using our Pythagoras theorem. So using Pythagoras theorem, we know that the tangent line of 12 units and the line of 2r, they are perpendicular lines, and the yellow line is a hypotenuse here. So we will be using the Pythagoras theorem as 12 squared plus 2 times small r squared equals to capital R squared. Simplifying it becomes capital R squared minus 4 times small r squared is 144. We will be substituting this value to our equation of the area, and we will be getting the area of the green region as 36 pi. Now we will be solving it using another approach that involves minimal calculations. We solved the problem in last approach using geometry and algebra, and we concluded to a constant solution, that is 36 pi. But here the radius of the larger quarter circle, the radius of the smaller circle, the placement of the tangent, everything can change. So why the solution of such a dynamic system is a constant? In this approach, we will be solving this problem using a very intuitive manner, and through this we will also try to understand why the solution of this system is constant. First, we will be assuming the remaining area of the larger quarter circle. I have recreated this problem using GeoGebra. GeoGebra is a very good tool to simulate geometry as well as other mathematical operations. In this, we have our quarter circle, a smaller circle, a tangent of 12, and the rest of the part of our quarter circle. In these kind of problems, where very less information is provided, what we can do is we can start dragging things to the extreme. That is, the only thing that is constant here is the length of tangent, that is 12. So we will start dragging this tangent slowly and steadily downwards or upwards. Before I do this, I want you guys to think what will happen when I start dragging this tangent downwards or upwards. What will happen and what will happen to this radius? You can pause this video and make a guess. So I will start dragging it slowly and steadily, and as you can see, the radius of our bigger circle has started lessening and our bigger circle has started shrinking. This way, if you can see, when we coincide this tangent with the radius of the circle becomes 12, and all we have to find is the area of the green region, that is the quarter circle. Now if I start to bring it back up, we can see how the radius of the bigger circle as also increases. This might create some doubts that why is the green region area constant through all of this. We can see the area of the green region as I have calculated it here already. In this, I have calculated it as area of P, that is the area of the quarter circle, smaller quarter circle, minus area of E, that is the area of this red region. If we see here, this is E. If we see, this is E and this is P. When I'm clicking on green, it is becoming P. When I'm clicking on the red one, yes, when I'm clicking on the red one, it is becoming E. So I am subtracting the area of P minus area of E, and this is giving me my final solution. If I start dragging it, everything, the radius of the bigger circle changes, but the difference stays constant. We can also see it as a solution of 36 pi. We've got a solution of 36 pi and it is remained constant throughout, as you can see. So that's it, guys. I want you all to try it out. If you have any problem, please feel free to comment about it. Thank you.